I Hello everybody. Uh, hey, hey, welcome to a slightly delayed podcast. Definitely, I'm not to blame here. We can blame some book, some traffic from room
Yeah,
one to
so some traffic from my calendar. Highly trafficked calendar.
Okay.
But yeah, there
Hey,
was a pileup.
better late than never.
Yes.
We'll definitely maybe we'll shoot over by about a few minutes, but we have some fantastic discussion today. But before that, Ed, what's on your mind?
Well, probably the most recent thing for us was well. There's lots of things obviously on my mind. Uh, Most recently, of course, we had our few fun days of Fable before it got yanked from us. Because actually probably something that is worthy of a longer topic, but
Yeah, yeah,
um,
of
but
course.
but AI safety and a lot of interesting things in that regard, but the possibility that the Anthropic Fable model had been jailbroken, releasing the full Mythos capabilities has been an issue, and so Mythos is no longer available. And this is, I think, probably an interesting topic for all of us, because we are, for many of other people on the call who are building agentic systems that are leveraging and depending on cloud delivered models, and so I think we'll our goal here is not necessarily to be doing, although we do plenty of times, hot takes to current events. To the extent that people are planning their model strategies and so on, we should talk about what some of these things mean. I think we'll talk about some of that in this conversation today, but probably there's a whole governance of models conversation that
No,
and selection and
yeah,
dependencies
no,
that is worthy.
yeah, yeah, I absolutely agree. I mean, it is a very, I was talking about, I mean, not I was talking to, I was listening to Lenny's podcast, and he had Benedict Evans
Yeah.
on, right? And the discussion really was, is the model layer like the telco layer, where where it's a big market but commoditized and you can actually switch in and out, right? Or whether it is actually you will tie yourself and bespoke to something. And those are all kind of really important questions given kind of how to at the frontier these frontier models are, and with all the issues that go on. So I think it's a very, very deep
Yeah,
conversation.
and the thing that people need to understand is that it's an emerging business, and the telco. Everybody says the telco model, but the telcos themselves did not choose the quote unquote telco model by choice.
I know.
And so,
I
uh,
remember the app store from AT&T and T and all that for a long time.
oh, I was actually going back further than that. As possibly some of our listeners know, my father was at Bell Labs through the original, AT&T breakup. When when they were broke up under antitrust back in the, I guess it was early '80s, or so, late '70s, early '80s, and uh, and so, look, with what we now think of as the telco model, where things are interchangeable and every phone service and phone and everything switches, and we have a wonderful world of interoperability, is something that again we
Didn't
got
just
to
happen.
that point.
It didn't just
Yeah,
happen. Yeah,
it
yeah,
didn't just
exactly.
happen. And so same thing. I don't believe, and I tell people this all the time. There's nothing that says that the frontier model companies just want to be API companies that just give you tokens for money.
No, no, of
They
course.
and there's no like, this business will figure its way out, right? And so, but that said, we're also now have some additional wrinkles that people didn't think about, which are that models are bouncing against that line. And as you pointed out, the book that you recently finished reading, Yudowski's book.
Yes. Awesome.
Um,
Yeah, yeah,
and
of
so
course.
it's an
Yeah,
interesting topic. The
of
the
course.
other
Yeah.
the other thing that, of course, is top of mind, at least for our very limited viewership. our opportunity to actually go and see some folks with a real viewership. The podcast that we're big fans of, which was Hard Fork Live in San Francisco. You and I and IBM was one of the sponsors of that event, and so we got to have a great seat and watch Kevin and Casey do a really great show that was very enjoyable.
Very enjoyable, right? I didn't realize Casey is that tall, but I'll tell you the session that I found most interesting, kind of on the borderline of kind of frontierness and not frontier, was they had both Daniel Kokotayo and Sayesh Kapoor kind of
Yes.
arguing about whether 2027, or now Daniel says it's 2028, whether it will actually happen or what are the impacts. And it was really, really very interesting to kind of see people who see things similar-ish, okay, and yet have such difference in the kind of outcomes uh, that would happen out there. I mean, everybody talks about diffusion is slower and all that stuff, but it was some really, really deep conversation that I enjoyed.
Yeah, no, I think it was great. The this was, but I guess my understanding is Sayesh and Daniel have been doing this debate up on stage several
I
times. At
yeah.
this point, there's I felt like they were at this point, like they've hung out so much they're like good friends and finishing each other's sentences. So I think, at least from the standpoint of polemic discourse, perhaps it's been quite tempered in terms of them slugging
they,
out the
they, they,
positions.
they, they should have had Yudowski out there, and then that
Sure.
would put a bit of a damper.
I think so. That would have been that, but it was good. And actually, but it's interesting because the other thing I will say that I was deeply impressed with both of them was that, and honestly, this it was a good reminder, really, for everything that um, is happening in this space, which was. Get past the headlines. They themselves, I think the interesting part and the reason why it was such a fascinating conversation was that most people sort of, do the TLDR and don't actually dig into their positions. And this was an opportunity, a very sort of civil, enjoyable conversation where they actually got into their points of agreement and points of disagreement in really just a very factual way where they acknowledged each other's position and so on. It was not. It was. I'll say a lot of the AI, and I won't name names. I think we all know who they are. But a lot of the AI pundits out there, for and against, and so on, are more trying to score headlines and going for scoring points and going for the headlines and so on. And there are deep, difficult, hard questions for all of these things that are worth exploring. And to the extent that anybody who's listening to this is not already familiar with Daniel and Sayesh's positions, go ahead and read these in depth because they both make many excellent points, different things that could happen or not happen, and so on. By the way, same thing for this whole conversation about the whole Fable ban. As some of the pieces have come out and you start to see the explanations, nuanced positions. You pointed out Ben Evans, Ben Thompson on Stratechery wrote up something good as well. A lot of good backgrounder on just what this all
This
means,
what
in,
exactly?
and it's not all just knee jerk stuff. There's sort of real questions that are being asked, and a very difficult time. And I think probably the one thing that perhaps has been most true, perhaps for some of these doom prognosticators, they might not be right about the doom, but they are right that choices we are getting to sort of intersection points where you have to go and say, hey, do we need to think twice?
No, that's absolutely right. And it was fun to see that humanoid robots are still a bit dangerous, and but all in all,
Yes.
we had a fantastic time, and the audience really liked it. And maybe before we pass the torch, we would be on stage somewhere also. But let's see. It all depends on our audience. Hey,
Yes.
so So with that, I want to kind of set up our main conversation. So obviously, LLMs have dominated all the discussion, and obviously LLM started with text, and now they are doing other modalities. But there are lots of other modalities that are not kind of amenable to the state of the art with respect to LLMs. And I wanted to kind of invite Vanya, who I've known for a very, very long time. Okay, uh, is going to Vanya Josifovski, right? Sorry for mangling that. Hello, Vanya, and
Hey,
Vanya
Anant.
I've known from 2000, and Vanya is just a very very storied person who's been pushing hard against and succeeding that there's another set of modalities that need to be considered as we move towards this world of fast move towards this world of AI. So Vanya, first of all, welcome very much. Okay,
Thank you so
thank
much,
you so
Anant.
much for your time. And why don't you tell us a bit about your background and what brought you here to what you're doing at Kumo?
Hey, Anant. Thanks for having me. Ed, good to see you again. Uh, what brought me here? Uh, you know, an airplane about 2000. The last time I came in the U.S. 87 for high school, 94 for grad school, and then finally 2000 when you gave me a job at IBM, my first
Yes.
job.
Hey, listen, it's just been a pleasure. For those of you who may be looking at some patterns, okay, we had Jun Rao just before 1 year, okay, and there are many others. IBM research has been just a fantastic source of phenomenal leadership across, and 1 year is just an example of somebody that I had a pleasure of working at IBM.
At the time, I think the only software industry that was making any money was relational databases. So that's
Yes.
what we did, and that's where I started my career. Then I went to search and search for ads and for web at Yahoo, and from there to Google, where I was in Google Research for 3 years. At that point, already working on what was called then machine learning, data mining. AI was a term that meant something completely different. That was usually applied to symbolic reasoning, right? And now it came back. But large scale modeling, large scale learning, infrastructure for ML, and then at some point I decided to do something else than research. Founded a company. Company got acquired by Pinterest. I became the CTO up to the IPO, and then I went to Airbnb. I was the CTO for the main business homes through Corona and the IPO, and then I founded Kumo to solve some of the problems that I saw in the industry at the time, but also throughout the 25 odd years through the valley here.
Yes.
And yeah, so that's the journey.
Fantastic. No, no, absolutely. And all throughout, kind of still dealing with data, but kind of different forms of data,
Right.
right? Uh, so you and I were together. I'm obviously older than you are, so I've seen slightly earlier versions of
Slightly.
slightly older versions. I've seen the world of databases and all that, and for a long time, databases, it was just a fantastic area. I mean, we all know VLDBs and Sigmods and
Yep.
and some really really awesome pieces of work. But then, but then it became okay. It's fine. SQL is what SQL is, and everything else. And now everything else, really, the large data is semi-structured, and big data and unstructured, right? So it kind of said, okay, it had its own space, but a lot of action was happening in kind of other modalities, right? And so
Yeah.
you have lived through both sides, and you chose to actually come back to the first. So tell me about kind of your observations on how this area of kind of science and engineering around relational stuff has evolved over time.
Yeah, by the way, I think database is in vogue again, right? So
Yes.
for a while it wasn't kind of the thing to do, so we all went and did something else. I think relational data at its basic form has been collected for centuries, right? I mean, you made a ledger because it helped you recreate the current state of the company. And that's the first use. Transactional databases solved that, enabled millions of businesses to be able to operate super efficiently and reliably in that way, to figure out what has happened. And then, about 2 decades ago, people started saying, hey, this is great data. And the relational structure is there because it's very useful to capture the history of the enterprise. Everything that happens, facts and dimensions can be thought of entities and events. And so everything, you have transactions, you have customers, everything is recorded there in detail. And then, people were like, hey, if we have this data, maybe we can do analytics. We can look in the past. We can figure out what's going, to happen in the future. That spawned a whole ecosystem of technologies. But I think also about 15 years ago, people started doing machine learning. That's like, take this data that we have, the history, and not only do a summary of the past, but actually do a prediction of the future. And specifically, this is very important on a very granular level. Like if you have 10 million customers and you want to understand what to do next with this customer, you cannot have a human in the loop that's going to do analytics and then move forward. So at that granularity, you have to just do the predictions. And these predictions can be recommendation, personalization, ads, health outcomes, everything. And so, that's the journey of this data. But however, it fell a little bit behind in the AI side of what's happening with computer vision and text. And the way I explain this, from everything I've seen, is I think, text and images and videos, to some extent, a little bit of a simpler data. You have this formalism, you can think with that. You have a matrix, that's the image. You have a set of pixels, and you can reason about that. You can develop mechanisms like convolutional networks that are fairly simple. It's a sliding window over the image at multiple different levels of resolution. I just, but text is a string, and obviously I'm trying to be a little controversial here. But what do you do with data in 200 different tables? How do you process it? And the usual machine learning things is like you take the data and you munch it into a single table that contains rows, and then they contain features. Features are basically signals that you manually think that they'll improve your predictions. And I think that's why relational data kind of fell behind, in terms of all this AI revolution.
Yes, and even in machine learning, right, it became a very sparse matrix, right? And relational stuff had generally been good for dense representations, right?
Right.
And now you've got 1,000 columns. That's why, for example, Ed and others ended up saying, look, we need some kind of NoSQL representation, which was both a query language but also a
Right.
representation which would allow for this kind of variance. In our times, there was this non-first normal form, but then after that, it evolved, right? Because people realized that some of the things outside the ledger and transactions, and especially in this web world, the shape of the data looked a bit different.
Yeah, you forgot XML. Remember how much time we spent on that?
Yeah. I just
Too
met
much
with
time. Too much
I
time.
just met with
It's yeah, exactly.
Don Chamberlain. For those of you who don't know, Don uh, invented SQL. I just still criticize Don. I just met him a couple of weeks back, and I said, Don, because of you, the poor compilers have to do a two pass because he decided to pick select before the from, and therefore you cannot actually argue. Okay, sorry. Yeah, go ahead. Sorry, we are all old guys.
So yeah, I mean, I feel that I'll tell you another anecdote from those times. And I work with Don and Ron, and the tabular format was invented because it was very suitable to optimize storage, because normalized schema does not repeat information, and to optimize ability to update. When you have something in multiple places, it's very hard to update. But I remember walking through the halls at Almaden, and there were these old books that people would just put in the hallway. And there were a lot of them on hierarchical data models
Yes,
that came before relational, and
IMS.
were
Yeah, yeah.
competing with those, right?
Right.
And so this data, although it's in tables, it's not really you can think of it in many different forms of shape. And the main insight we have at Kuma is that you can take tabular data and you can think about it as a graph. And so you have every row roughly being a node and every foreign primary key connection being a link. So this is not a graph of your tables. It's a graph of the actual data. So if you have a data warehouse with 100 million, 10 billion nodes, you're going to have a graph of 10 billion nodes. And now at Kumo, we have adapted the newest, I would say the latest advances in AI, and specifically transformer architectures, deep learning architectures, and foundation models to work on graphs. And with that, we are bringing the same benefits. That means that you can solve multiple problems. You don't have to train a task-specific model as we do in ML. Like you have a recommendation model, you have a churn model, so on. Here is one model solving it all. And second thing, you don't have to
So
do
an
manual
example of
feed.
problem would be that a generic transformer-based Kumo model will be able to both do a churn prediction, okay, as well as next best action prediction, as well as
Yep,
a recommendation prediction, all on the
yep.
same data.
Yep, that's the short answer is yes. There is more
Wow,
complexity to it, but we can
wow,
go through that. And not only that, but it can recommend on a scale of 3 days, 5 days. You can define churn as not having transactions, or you can define churn as having transactions that will sum up to less than $15 or $50, or you can say having less than two events and transactions below something. It's almost we have like almost like this because I work with Don as well. I guess a SQL like language. Instead of select, it uses predict, and you basically tell it the quantity that you want to predict, and you tell it the time range over which it's going to predict, and you give it a target of prediction, like be it a customer or a product. So the same model can predict stuff over products and over customers over the same schema, and it can ingest any types of schema, like SQL. We run the SQL query, over any kind of schema.
fascinating. You have some equivalent of an attention mechanism. We'll get into some
Yeah,
of those
Yeah.
details,
yeah. I'll
right?
tell you about that.
Ed, go ahead.
No, that's what I was precisely. I was actually kind of curious as to so because we're starting to hear this type of thing where people are actually going back and leveraging some of the components of the transformer model in ways that are not immediately obvious to people who have the great thing has been over the last couple of years that we've been able to turn these models, the current generation of LMs, into sort of units of work, if you will, that software engineers are able to reason around. But this is sort of an important reminder that they themselves are an assembly and can be reassembled and
Wow,
reconfigured in different
wow,
ways. And so this is what I'm trying to. This is at least that was
wow.
my what I was thinking as you were describing this in terms of understanding what you've done here. So I'd love to hear a little bit more about sort of
Yeah,
how that comes together.
yeah. So I would just preface that by saying that this type of a tabular graph foundation models are probably where large language models were maybe 2020. And so it's early, and a lot of things going to change in the next few years. Okay? So I can tell you what we have done, but we see many, many different ways to move things forward. In terms of technology, I think there is analogies and sharing with learning over text and learning over videos and images at a conceptual level. In terms of specific implementation, it's way different. And I can describe where things are similar and
Yes,
where
we'd
things
love
are
to.
different.
We'd love to.
Yeah,
And
give us
also,
give us
So,
yeah, yeah.
the high
And
level
also,
of that. Yeah.
when in the end, at least the LLMs had the advantage that there was a public crawl that they could get access to
yeah,
all right. So where was the data that you trained this
yeah.
fellow on? So
Okay, I have
both
to
of
put
those.
all
First,
these
how you built
questions on
it,
the.
how you
on
built
the
it, but
stack.
also yes,
Yeah, you
yes.
might need to
There are
repeat now because I have too many questions and
it's on the stack. We'll remind you. Don't worry.
I think where the the network architectures, we had all kinds of image processing architectures. If you remember 2010s when it started, and so it became, and then text as well. It's the word to vec, move
Yes, of
forward.
course.
I feel that there is analogies here, and this is kind of a pattern. Like let's talk to text. Like we used to do RNNs,
Yes,
recursive neural networks, right? And
yes.
so you process a text, you process it as a sequence, and before that we had hidden Markov and all of that. So but the concept here, and it maybe to several of these different models, was that you process the text as a sequence, you have a state, and as you process every word you update the state. And now if you want to focus on the next word prediction, which we do mostly in large language models, when you run out of text you'll use the state to predict the next word, right? What transformers kind of did is they don't bundle this into a state. They look at the network, look at all these different words, and kind of simultaneously figure out the combination of where the information is. It's like a little light shining on that, and that's used in the next layers to predict the next word. So the complexity is much bigger because
Yes.
you don't bundle it. It keeps things separate. You have to reason in combinations of these separate things, and this is very conceptual kind of description. And there were similar state-based models in other areas, like even in graphs. We have graph neural networks, which are very powerful way to combine information in the graph. And so you have a node, you want to predict something for this node, you can basically go multiple steps further in the graph and figure out how to propagate that information through message passing to this node to be able to predict the quantity. But yeah, again, it aggregates over the steps.
You're not
We
talking about eigenvector and eigenvalue calculations. You're
No,
talking something
no.
deeper than
It's
that,
just a
right?
message passing system, and you have, each node. Then you kind of learn how to combine the information from the node, right?
Okay.
Graph transformers work in a little bit of a different way. So, given a node, if you want to say predict churn, what you're going to do is you're going to look over all the neighboring nodes. And now I said that the links are foreign primary keys. So
Yes.
if you're a customer, all your transactions, all your clicks in some cases, and everything else that's connected,
Is all
you know,
context. Is all
right.
context.
And so now, but this are heterogeneous nodes. The transactions and clicks are different.
Yes.
So what we did is we implemented something that would do multi-head attention. So you would do attention over transactions, you will do attention over clicks. And again, I'm simplifying things, but you could then figure out which transactions are important to say to predict churn or if predict fraud. And so now that's conceptually very similar to attention in text. What's different is that you can have tens of thousands of events. And so, and not only that, but then each of those transaction events is a very complex event because first and most important, and the biggest difficulty to do this right was time. These are temporal graphs usually. So you have time events, right? The second thing is it's a tuple. And so it will, maybe I'm using the old terminology. It's a record, right? So it will have
Or a row. Or a row.
product row, product type. It will have a store. It will might have then connect, and it's connected to other nodes because then you have brands and so on. So imagine now doing this attention over these transactions, but then you take specific transaction. It has a product, and then that product has other users recursively in the graph. So then you can attend over those users and see what kind of patterns between the users who bought this particular product can be brought in. So doing attention in a graph because of this explosion. Like if you have a node that's very popular, like you, for example, on LinkedIn having tens of thousands, and then maybe you have hundreds of thousand followers now.
Of course.
It explodes once you hit that node. It
No,
explodes.
you're confusing me with Mohan. Please. So
Hi, Mohan.
I'm Ed
We have at
doesn't know
least
who we are
one
talking
viewer.
about,
I
but
don't. Yes.
So
I think Mohan broke the LinkedIn limit of 65,000 something something.
he's a great guy. I remember Mohan really well. And so, so the scale here is daunting. The time is a problem. And I feel that why hasn't anybody cracked this before is because graphs simply do not have a natural sharding dimension. Like with images with text, a document, you put it in one machine. And then if you want to scale, you're just going to shard those documents. Like sharding graphs is really difficult. I think in my
Yeah.
career, I tried 3 times to build a distributed graph system that will shard things efficiently, and I failed. So
But wouldn't time be a good unit for sharding?
you could, but you don't know how the signal propagates through time. Like sometimes
Yes.
the last 3 things you do are very important. Sometimes the whole history of things you
Yeah,
do.
yeah. And you may
Sometimes the
not be
last
you
three
may yeah,
months.
exactly. It may be months
And
before you went and saw the doctor again,
and I can
right?
give you an example of why I know this is the case because in my prior job, I had a
Okay.
ranking model,
Yeah.
and that model had hundreds of features which are based on aggregating prices of events. It's like hundreds of features. Somebody aggregate because a data scientist will make a
Oh,
new
they would roll
feature.
it up by a day, a week,
Right.
right?
Three
Oh,
days,
wow.
5 days, 6 days.
Yeah, yeah,
And
of course.
then, the best way to show an impact is you add a new feature to the model that nobody else had it before, and you show 1% up, and then you're done, right? So here, the network learns how to do these things. It actually learns correlations, it learns aggregations, and all of that. It's magic.
It's absolutely fascinating. Okay, uh, then topic number two, Ed, if I can go on, was assuming this is all fantastic. It clearly is. Vanya, I know you. I know of Hema and your other co-founders. So you guys are brilliant folks. So I'm sure what you've done
Thank you, Anand.
is fantastic. But where's the data that you could run this on?
Yeah, yeah, that's a good question. So we started building task-specific models for very sophisticated customers, and we saw these patterns, similar patterns. So what we did is, you know, we that's another similarity with maybe textual models is that when we started building this, we realized that we can rely the majority of the cases of synthetic data. And actually, it's mostly, I would say, 99% synthetic data at this point, even more than that. And then, you know, we do some fine tuning with real data. But look, tabular data sets you can find in troves out there.
Yes, yes, of course.
You can build an agent
But
which
it, but
can go
it, but
and
it
figure
won't tell you
out.
when it won't tell you when Ed churned, right? If you're predicting churn, you would need to know that that your signals you had till January were like this, and in March he actually churned,
I mean,
right?
if there's no event in the data set after 30 days, then ad has churned for those 30 days. So you can.
Ah,
Interesting.
interesting,
Yeah.
interesting,
So,
fascinating, fascinating.
but in the synthetic data set or in your, I mean, I guess I get that's where we're starting to get into the intersection of the training
So
set versus sort of the
right. So
business rules.
right. So and I omitted a lot of different things. Like when you do
Right.
this attentions, you do attention across the graph, which I described. Then you do attention over the row itself. Then you do attention over the columns. So it's a combination of multiple different attention mechanisms to get the best performance. I mean, it takes some time. I think it took us about probably 18 months or something like that to figure out the data generation stuff. But once you figure it out, and it requires some thought, you know, how you put this to make sure that you cover enough space, and eventually we got it right.
Reminds
But
me, I think a lot of the self-driving cars actually train on synthetically generated data.
I mean, you see this more and more. I mean, you see also for areas where there's not enough data, like fraud. I mean, you have so few labels, you can, people are already using agents to create data and so on. We haven't gotten to that stage, but I think that's coming as well.
Fascinating. So the two things is, number one is applying at least transformer concepts
Right.
to kind of graph. Obviously, only at a very high level they are parallel, but their specifics are very, very different. But the concept of attention and which part you want to focus attention on,
Yeah.
and computing those kind of vectors probably holds. And then second is where is the data, and the data is
And,
synthetically
and, and
built.
look, you need to build
Well,
an infrastructure that makes this super efficient. And the name of the game today is you have CPUs and GPUs and multiple different types of systems, and you need to keep your GPUs busy. If you keep your GPUs busy,
All good.
then things go fast, right? And
Yes.
for GPU, you need to be able to cut a piece of the data and send it down in a limited, it has to be, constrained amount of size. And so you need to figure out a way to take a graph of billions of nodes, hundreds of billions of nodes in some case, and to map the
Yes.
task
Yes.
into a memory
Yeah.
constrained amount
Yeah,
of
yeah,
work
yeah,
that you
yeah,
can
yeah.
send down to the
Yeah, the
GPUs. And
kind of the embarrassing parallelism of text doesn't hold. So you have to be very, very
yeah.
careful about how you do it. Awesome. Ed, you were saying
so
something.
yeah, well, I was kind of curious just on the previous point. So the models that you're training off of this synthetic data, these are models that your customers are so these are models that you are training from the synthetic data. And then you're providing these models to your customers as is. Do they further fine tune or train them, or is it or are you then providing the system that they use to train on their data? How does that work?
So yes, you can, and I feel that there is this again, similar to the large language models. You can take this model out of the box
Yeah.
and get a prediction out in up to a second without training any models.
Yep.
And so, and this is done with what's called in context learning. And this is a concept that also been used with large language models.
Right.
That means that if you want the model to make a decision on a task, what you do is you sample the data and you provide the model a set of examples.
Yes.
Like, this is churned user, this is non-churned user, this is churned user, this is non-churned user. You say you provide 10,000 examples, and then you give the example without a label. And then the model provides you the answer back. Okay?
Yep.
I think, in context learning is something, I think it's all about how do you use your private data. So this is a way online you can assemble that fairly quickly, that, I say sub-second usually. And you can, we're going to make it a lot faster. You can assemble that set of examples and then you can, give it to the model instantaneously, but you're still using like a tiny fraction of the overall data,
Yep.
right? Another way to use your private data is to fine-tune a model, right? And when you fine-tune a model, that's a higher level of effort, but you can use a lot more of your data. And so the question is, it's a trade-off here. How much effort you want to put into fine-tuning the model. Now, you can also fine-tune the model and have a generic model for any task, or you can fine-tune it down to a single task model, similar to what we're doing in machine learning. And then you might get even better performance. And a lot of this application, a 3% improvement in model performance is a 3% improvement in revenue.
Yes, that's right.
So,
Right.
so we are not at the point where this technology has a universal answer still. You still have some options of, how would you use the model? Like
Because you're
in the
saying it's
old,
still circa 2020, right? As opposed to
it's circa
2026.
2020. That's
Well,
what I
but
think.
circa 2020 is it might be a little even more recent than that. So I think it's the interesting piece on this is that the result of this. So for a long time, and I forgive me if I'm being a little oversimplified, but for a long time, sort of what you had in the state of ML was, you had people going and creating by today's standards, not super sophisticated models, but at the time, and I am talking about 2020 or so on. And you had people, and they were using whatever to go and train and create models on their private data sets, and because domain specific, because that was the only way to do it, because you
Yep.
didn't have these public data sets of sufficient public data sets of business, whatever business transactions brought from things like you just talked about in terms of fraud or predictions or so on. And so then you sort of the switch flipped the other way in terms of people now using language models in for a lot of things that they previously were using ML models for, just because the model can brute force it. But one of the things you're
Oh, so
pointing
you're
out
saying
here is
is
that,
give it a spreadsheet and say predict, and
well, what I'm saying is that what I'm understanding is that one of the interesting things here, one of the breakthroughs here is that the generation of synthetic models and the mechanisms that you're using for breaking up the problem now make it possible for a vendor like yourself to go and offer, you know, domain things previously that the customer would have had to actually train
yeah, yeah, yeah,
from
of course,
ground
exactly
up
right.
on their
Yep.
data. Now they can get off the shelf from you and then use in context to get the rest on their data. So what it means is that they actually get the best of both worlds, which is really fast. Here it's out of the box
Yeah.
results on their data without having to ship their data off to have a model trained on, right? Which was the big
Yeah.
objection. And so that's a big deal. And I think it's an important point, probably for a lot of the folks that we're talking to here who are in enterprise settings where they probably were sort of falsely thinking of the previous dichotomy, which was either either I have to have a bunch of experts to train these models myself, which is time consuming and it's most of those efforts have failed, or I need to ship my data off to somebody else who's going to see all my secret business data, or I just have to use an off-the-shelf language model, which is going to sort of brute force it, but not actually be particularly optimized, or and so on. And you've kind of would you've your mechanism actually gets around that. So this is it's I think I'm taking it in a slightly different direction. What I'm saying is that for some of our folks who are sort of evaluating these model-based solutions, this does represent a sort of new generation of more flexible
Yeah, yeah.
domain-specific
That's
models that are going to be off the shelf.
Yeah.
And so I do actually think it's a kind of a big deal for people who are sort of figuring out their strategy for applying these things.
I think where you're getting. I think you're onto something. Is like, what are your options today? Like we know
Right.
what your options were 10 years ago. As you said, we train a model. You spend 6 months. You find the features. Maybe you reuse some of the features from other models, but it takes a lot of time in doing this. You have millions of pipelines running today in enterprises that have this type of predictive models there. The question is, what would you do today? You would definitely use an agent to rewrite your pipeline. You will not write it by hand.
Right.
So that's first. Now, if you use an agent today to write a pipeline, predictive pipeline, it will write a predictive pipeline likely using something like XGBoost,
yes.
which is an amazing technology. But it's not using deep learning, and you don't get all the benefit. And I think even today's models, the code that's written for this type of things is usually slightly off. But I think it's going to get fixed. Like in a year or two, it's going to be at the point where it's going to work correctly. However, if you use an agent to write the code against Kumo, you, instead of 1,000 lines of code and this brittle kind of feature engineers in the code and Spark code that produces these features, you'll move a lot of the computation from code into the neural network. So your code is going to be shorter first. And second, neural networks are a lot better dealing with data because they automatically adjust to it. If data changes over time, your features will change, the network will change itself and so on. So you get something that's much more reliable, that's better, in terms of model performance, and it gives you flexibility. Every time you retrain, it figures out the new patterns. You don't have to, find new signals and so on. So the same way that, your agent will not write XGBoost yet, so we don't know where this is all going. That we provide Kumo as a toolbox in the agentic, and then on the usage
So
side.
just on that point, Vanya. So Andre Karapati is on record to say that look, there's software 1.0 and 2.0, and one of the big shifts that he said going from 1.0 to 2.0 was a lot more work is being done in the neural network. So clearly that
Yes.
that particular point holds. Yeah, go ahead, Vanya.
No, so what I'm saying is like you then on the top of that open new applications, because if I can sketch in 30 seconds the enterprise of the future, you're gonna have an AI enterprise platform of a sort, and then you have agents working on the top. That's the new
Yes,
enterprise,
yes,
right? So those agents will be working with data and so on. Now, if an agent wants to make a decision, and they will have to make decisions, the best decision is based on the data. Like if I'm in a hospital and the agent needs to make a decision if should release me from the hospital, it could look at the model that's trained for patients like me and predict if I'm going to have complications upon release,
yes.
right?
Which is right now
Now,
in the doctor's brains with
which
respect
is
to
in the
right.
doctor's brain, or somebody needs to build a machine learning model, and that is, imagine instead of that, the agent being able instantaneously to ask the data and get back a prediction from the data. So this is predictions are usually best based on data, right? In that second or two, what's going to happen with me, and make this decision on the spot. That's an application didn't exist in the ML world, where you had to anticipate every
Right.
question you make. So it opens new applications and allows for rewriting the existing pipelines with something more performant and more reliable.
Awesome.
Yeah.
Hey, a couple of questions. So this is great. So no, this is really awesome.
Thanks, Anand.
But there's a different word now. Of course, some of
Did I
but
pass the
then
interview?
you pass the interview then and every other time, and thank you. But it's a private joke, guys. Uh, but then the second part of it is that the textual modality doesn't go away, right?
No.
So are we still left with kind of joints outside, right? Which is always a problem. Do you go left or do you go right or do you go on both sides? And how do you kind of mix and match? And the kind of standard problem of federated predictions, of federated joints, of federated this and that. Who do you give more importance to? I know we are probably getting ahead of the thinking here, but that would also be a problem that would need to be solved over time, because if you have two different systems doing two different things, then how do you kind of combine the results?
Well, SQL Med, part 9 of the SQL standard, right?
Oh my God, like the equivalent of like. By the way, I always thought,
Garlic.
Ed, this is a joke. I always thought that med stood for medical, it stood for media. Okay, so it was a big surprise for me,
And then it stood for managing external data.
Yeah, I know. I'm just kidding.
Ah,
So trying to solve the federated data problem 26 years ago, right? But I think that part is solvable. Look, first in Kumo you don't need to pre-join the data. Just give it a schema and it figures out. So you don't have to
Yeah, of
pre-join, or you
course.
don't have to figure out where the signal is, and so on. So that part goes away. Now the part that you mentioned, if the data is in another store, that needs to be figured out by code. And that type of code agents can write today.
Correct. Yeah, of course.
yeah.
I get it. I get it. So you want to be, so in your world, there's a class of applications where you are the master of the domain and you pull in the data as needed. Perhaps agents are writing it. As opposed to in the LLM world, LLMs are the master of the domain and are answering questions, and then through RAG or other techniques that Ed talked about, are pulling structured data into their world, right? So it's kind of who's on top, and there's a class of problems where the LLM world makes sense, but there's an equally large or larger class of
Yeah.
problems that where you being the king of the world makes more sense.
Yeah, I think Kumo exposes today through MCP. An agent can call Kumo as a tool, as it calls RAG, which gives you a textual retrieval. Here you get prediction service,
Very good.
and
Awesome. Fantastic. Before we let you go, can I ask why Kumo?
why the name Kumo?
Yeah.
Every company has a myth of creation. You want the myth or you want the real?
No, no, I want the myth. Myth will
Give,
be
give
more
us an
interesting.
if it's a good myth, let's
Yes,
we
myth,
prefer
myth will
the
be.
yeah.
So
Yeah.
Kumo means spider and cloud in Japanese, depending on the context, I guess. And so we
Ah,
were, we do graph-based learning, so that's the spider web, and cloud because of the cloud era.
Fantastic.
And it was also one of the .ai domains with 4 letters that was reasonably priced when we started.
Yeah, I paid. People forget how important that is.
so one of those is the truth.
Okay, no, this is super duper
That's
awesome. Hey,
both
listen.
of the truths.
Uh, hey, Vanya, uh, thank you so much. I've been following you seriously for a very, very long time.
Thank you, Anand.
And I knew you're doing some really fun stuff, but I think that I've learned a lot with this conversation, and hopefully our audience has too. And we should get you back as we make progress, as we go from 2020 to 2023 to 2026 in this space, especially for our audience. They absolutely understand that this whole world is evolved, but the structured data world is as important as that. So how do you kind of bridge the gap? I think it's really, really important out there.
Well, thank you for having me. I would just say at the end is that we have a whole pile of new ideas of how to make this much better. So new ways of doing things, borrow stuff from robotics. It's just you know how research works. You get inspired by something else which is a little bit further out, and we're super excited of what the world of the research world is bringing. So in some ways, I'm back to research.
No, this is just I'm telling you that is the awesomest thing. Now with kind of AI and AI coding, you can actually go from research and thoughts to actually seeing whether that idea works or doesn't work much faster, right?
Yeah.
Whereas previously uh, it was a slightly longer path. So again, Vanya, thank you so
Thanks so
much.
much.
Really, really appreciate it. Say hello to all your colleagues,
Thank
and
you.
we'll be in touch.
It's
Thanks,
great
Tim.
having you.
Bye.
Take care. Yeah. So that was really cool. There were a lot of elements of that that really were food for thought. Obviously, this piece of structured data, um, uh, new ways of thinking about it. In fact, the graph conversation did not go precisely the way I had actually expected. I think we're more used to sort of these knowledge graphs when we talk about graphs. He's doing actually a lot more interesting, deep stuff there. So I don't know your reaction to that, but
No, no,
I thought that was pretty cool.
I absolutely. I mean, as I would say, that and this, I'd always thought about where's the data. So I think both of those things deserve kind of deeper thinking. And what I can vouch for is that while there may be some kind of hacks around what he's done, and obviously as a CEO, he's kind of touting this is awesome, but given his research depth and what a deep thinker he is, and having done stuff at Pinterest and Airbnb, I think this is just groundbreaking with respect to how to handle kind of pre-trained models as opposed to training using XGBoost after the fact. So it was just an
Well,
app. Yeah,
absolutely. I think
absolutely.
that was the other interesting piece of it that um, the synthetic data piece is a pretty big deal, and is making a lot of innovation for these types of companies more possible. the one of the things that has been a gatekeeper for building various types of model-based products has been the data set. And it's the story that doesn't, it's the aspect of the story that often doesn't get enough coverage. Although obviously, like in the case of Meta, right, they spent a lot of money to try to solve that problem.
Yes.
And
Yes.
so that said, a lot of these new models, particularly a lot of these recent open models that we see being dropped, they have a lot of, in fact, some of them are 100% synthetic data, and as well as these sort of these domain specific. And if you look at what they're doing, so thought that was super interesting, and I think that that's going to uh, yield a proliferation of, specifically within the enterprise, you're going to be able to get a lot of off the shelf models that just previously were not available in specific domains, just because there was a scarcity that people, if you were a vendor who wanted to tackle this, you suddenly got into this issue of nobody wanted to share their data with you and so on. And now it's entirely possible to, still not super easy to do, but it is possible to build a training set without direct access to company proprietary data that then you can use that model and then give it to that company to work on. And so it just goes to show you that there's a lot of area of innovation. It is not. I think a lot of people. I think that sort of that aspect of model creation has somewhat, people have not been as focused on that because they've just assumed that we're moving into this winner takes all in the giant frontier model category.
No, no. Absolutely awesome. Hey, and a couple of other observations, right? I mean, in on kind of the structured data side, there's generally a huge amount of effort to kind of cleanse and standardize and normalize and this and that and everything else. Whereas on the unstructured data side, the models have become fairly good because they kind of start with some embeddings as kind of the first level or first few levels, and it doesn't really matter how you say it or what you say it, it'll kind of come all together. So that is itself a massive reduction in the effort for the enterprises to use the model, that they don't really have to do so much more with respect to kind of prepping the model. They still have to do rags and other things. So if that same kind of give us your unwashed masses, then we can do some of this work on your structured data. I think it'll also be really, really transformative with
Yeah.
respect to how enterprises actually leverage their structured data.
Agreed. Agreed. Well, this was really exciting. I think, and we didn't even get into any of the other news of you know, Cursor and SpaceX and all the other good stuff. Fable, like we got to do more of these. There's the world is moving too quickly, but I will say that the quality of the people who've been joining us have been amazing. Hopefully, people are enjoying this. This was a fantastic in depth stuff, and of course, uh, I'm not sure whether we're able to talk about all the good things, but Vanya had his own cursor moment, I guess, in terms of
Yeah, yeah, yeah,
good stuff happening to them. So
yeah,
um,
yeah.
yeah,
Absolutely. Okay. Awesome. I see that you've converted your garage mm, uh,
yeah.
into your study. So it's awesome. It's why don't you line it with bricks? So now it'll look like your older
My
San
old
Francisco.
office. Yeah,
Yeah,
that's
exactly
true.
right.
For the location of the Context Window podcast is relocated to what appears to be my garage, but it actually is not. But I am up in the Berkeley Oakland Hills,
Yeah, yeah.
as opposed to being in downtown San Francisco. So, yes.
Awesome. Hey, listen, fantastic. So next week, Silas will be joining us. Why don't you do a bit of what that background is?
Yeah, so we will have Silas
Silas.
is
2 weeks from now.
one
Yeah, yeah, yeah.
Silas led design at DataStax before that. Number of other great companies, New Relic and others, as and now at IBM is doing a lot of good work in figuring out how to deliver agentic experience around design. um, and so he's going to come and talk to us about some of those topics because, the whole question of how user interface has and design has morphed in the age of AI is a really interesting topic. One, how do designers work? Um, has changed a huge amount. You and I got to see Dylan Field of Figma at the Hard Fork conference
Yes,
last week,
yes.
and so obviously the tools of the trade have changed. The way that designers think about it has changed, and then the products that they're building have changed pretty significantly. And so I think we're going to cover all of those topics. I think it's going to be super interesting. And Silas is at ground zero and all that. As long as we don't get him on his other favorite topics like OpenClaw or crypto, I think we'll be good. Or maybe he will,
Why not?
but it
Why
should be
not?
a
We
lot of fun.
should. We should get. We should. I would love. I'd love to debate those two.
Yes,
Uh,
yes,
uh, hey, listen. So that's absolutely awesome. Uh, Ed, I generally act as the admin for some of the other brilliant people who I have to remind them, somebody that I have to say, okay, remember there's a call coming up. So I'll act as your admin from now onwards, and
yes,
make
yes,
sure.
yes. I
Uh,
and for all of our listeners who still made it to the end, yes, we very nearly almost didn't have today's podcast because I had the time wrong on my calendar. So, very
no, no,
appreciative, Anant. Thank you very much.
no, no,
And
absolutely,
yes,
absolutely. Okay, hey, listen, that's awesome. Again, let's thank our wonderful producers,
yes,
Michelle, Hannah, and Milan. So thank you
yes.
very much, folks, and take care and see you in a couple of weeks.